Hello everyone, myself Manisha Sawant. I am from Vidyadeep Institute of Engineering and Technology. Today we are going to learn about. In last lecture we completed limits and differentiation in complex function. Today we are going to learn about analytic function. First of all, what is analytic function? A function f of z is said to be analytic at point z is equal z0 is equal to x0 y0 x0 plus iy0 if the function is differentiable at point z0 as well as it is differentiable everywhere in the neighborhood of z0. It means function f of z is differentiable at z0 and the neighborhood means nearby every point of z0. Okay. For example, f of z is equal to z is analytic at each non-zero point in the finite complex plan. Second example is f of z is equal to modulus z square is not analytic at any non-zero point because it is not differentiable at any non-zero complex number. Okay. Next, some remark regarding analytic function. First is analytic functions are also known as regular or holomorphic functions. Second is a function f is analytic everywhere in domain D if and only if it is analytic at each point of domain D. Okay. Third one is a function f is analytic everywhere in domain D, then f is entire function in D. So this is remark for the analytic functions. Next is Cauchy-Riemann's equations, CR equations. The CR equations are necessary and sufficient conditions to prove any function analytic. So let's see what is Cauchy-Riemann's equations, means CR equations. We take here two functions, if u of xy and v of xy are real single valued functions of x and y such that del u by del x, del u by del y, del v by del x and del v by del y are continuous in the region R. We already studied about continuous function, so you can revise continuous by my previous videos. Okay, we have take two function real single valued function u of f of x and v of x of y, v of x f of u of xy and v of xy, and the first order partial derivatives of del u by del x, del u by del y, del v by del x and del v by del y. The first order partial derivatives are continuous in the region R. Then del u by del x is equal to del v by del y and del u by del y is equal to minus del v by del x are known as Cauchy-Riemann's equations. It means CR equation. Okay. So what is CR equations? Del u by del x is equal to del v by del y and del u by del y is equal to minus del v by del x. They are known as CR equations. It is necessary and sufficient conditions to prove any function, analytic functions. Okay, but necessary is the first order partial derivatives of u and v's are continuous in the given region R. Okay. Next, necessary sufficient conditions. Okay, we already studied that. Okay, the necessary sufficient conditions for the function f of z is equal to u of f of x, u of xy plus I v of xy to be analytic in the region R. First condition is, as I told, del u by del x, del u by del y, del v by del x and del v by del y are continuous functions, okay, of x and y in the region R. And second is del u by del x is equal to del v by del y and del v by del y is equal to minus del v by del x. It means CR equations are satisfied. Okay. If CR equations are satisfied, then we can say the function is analytic function. Next remark for the CR equations. First remark is CR equations are necessary conditions for differentiability but not sufficient. Differentiability but not sufficient. Second is, if f of z is equal to u of xy plus I v of xy is an analytic function, then u of xy and v of xy are conjugate functions. Okay, if f of z is equal to u of xy plus I of v of xy is analytic function, f of z is analytic function, then u and v both are conjugate functions. It means u and v are conjugate to each other. Okay. Third is, if a function is differentiable function satisfy CR equation. If a function does not satisfy CR equation, function is not differentiable. Okay, function is differentiable, function satisfies CR equation. If function does not satisfy CR equation, it is not and differentiable. This is necessary condition. Fourth one is, if function is differentiable at point x0, y0, then derivative at z0 is given by f of z, f dash of z0 is equal to ux x0 y0 plus I vx x0 y0 Cartesian form, and in polar form f dash z0 is equal to e raised to minus I theta ur r theta plus I vr r theta. It means ux means partial derivative with respect to x, vx means derivative with respect to x. Okay, ur means derivative with respect to r and vr means derivative with respect to r. Okay. Next is Cauchy-Riemann equations in polar form. Okay. Del u by del r is equal to 1 by r del v by del theta and del v by del r is equal to minus 1 upon r del u by del theta. Okay. We now stop here. In next lecture we are going to learn examples. We will see example of analytic function related to Cauchy-Riemann equations. Thank you.